Hello guys. So today we're looking at this concept known as significant digits. Some even call it significant figures. Okay, before we begin, I have a little measurements that I want to do. I have Pikachu right here, and I want to measure how tall Pikachu is in centimeter. So I have a little ruler beside Pikachu, and we're going to measure how tall Pikachu is from the tip of his ears to the tip of his toe. Now you're probably wondering, why did I say he? How do you know that this Pikachu is not a she? Well, to do that, you look at the tail. Okay, a female Pikachu, its tail looks like this. Okay, for a male Pikachu, it looks like this. You don't believe me? You can check it out for yourself. All right, enough of that. So, if you were to measure Pikachu, what's your results going to be? Well, what's certain is that Pikachu is going to be between 2.0 and 2.5. Okay? And we're looking into centimeters here. That's certain. So what you can be certain about is the 2. Okay? This has a certain confidence in it that, that 2, I'm sure. What I am not sure is the first decimal point. Now, let's kind of estimate here, okay? So it seems like Pikachu from the toe, okay, should give me around like maybe 2.3 centimeter. Okay, that's a pretty good estimation if you think about it. But is it dead on? Is it really 2.30 centimeter? Could be through 2.31, right? It could be 2.32. It could even be 2.29. So what does that mean? Well, what that means is that this 3 right here has uncertainties involved. So it's uncertain. Because I can't say for sure that 3 is a true 3. Okay? Why? Because I guessed that number. Whatever this is, I can't confident enough to say that, oh, that's a 3. That is so a 3. But I am confident that this is a 2. So, for every measurement you make during an experiment, there are values that are significant and there are values that are insignificant. And that's what we want to learn right here, right now, the idea of significant digits. So let's take a look at the rules here. Okay, for significant digits. So let's take a look at the rules. There are 4 simple rules, okay, that you need to know. And before I begin, just to let you know that numbers 1 to 9 are always significant. So they're significant digits. Let's call it SD. Okay, so let's go over the rules. So since 1 to 9 are significant digits, what that means is that the number 0 will determine something, I guess. So let's take a look at the first rule. Let's say rule A. So when you have a 0, okay, and this 0 is between significant digits, this 0 is said to be significant. Okay, so 0 between significant digits are significant. So this 0 do mean something. Now let's take a look at some examples, okay? So let's take a look at the number 623 grams. It has to be a measurement. Can't be a dead number. I'll tell you why later. If I ask you, this number, 623 grams, how many significant digits are there? Well, as I said right here on top, any number from 1 to 9 are considered to be significant. So 6 is significant, 2 is significant, and 3 is significant. So my answer here, of course, is 3. All 3 of these numbers are significant. All right, let's take a look at another example. This one will have zeros in it. So 6,003, let's say milligram. How many significant digits are there? Is this 6 significant? Yeah, it's always going to be. Is this 3 significant? Certainly. What about these zeros? These zeros are between significant digits. Oh, that means they are going to be significant. So the number of significant digit here, of course, is 4, because all 4 of these numbers are important. One more. 70,102 kilometers. Well, we can be sure that this is going to be significant, and whatever is between 0 or not, they all count. So therefore, your answer right here should be 5, because all of these guys are important. Okay, so that's rule number 1. So let's take a look at rule number 2. For rule B, we say that zeros to the left of significant digits are not significant or insignificant, whatever way you like it. Okay, so when you have zeros to the left of significant digits, they're not significant. Now, you may be thinking, well, to the left of significant digits, to the left? The only time I see a situation like this is when I have something like this, a number like this. Let's say 0.0016 kg. Okay, as you can see, these zeros are to the left of significant digits. What that means is that they're not significant, which means these zeros right here are insignificant. Only these 2 numbers are significant. So the answer here, of course, is 2. Okay? Only the 1 and the 6 will be significant because these zeros are to the left of significant digits. All right. What about this one? Okay, how many significant digits are there going to be here? Are these zeros significant? Well, just like what we saw with the first example above, they are not. So only the 3 numbers 1, 7, and 3 are significant. One more. 0.01001. Let's say milliliter. Okay, now how many significant digits are there? Well, we see the fact that these 2 zeros are going to be insignificant, but what about these zeros? Well, you get to imagine the fact that in rule A, zeros between significant digits are significant. So what that means is that these zeros are significant. So what that means also is that all 4 of these digits, they all count. So it's 4. All right. Next rule, rule C. So what if you have zeros? To the right this time of significant digits, and they are there after the decimal place. Well, if that's the case, those zeros are actually significant. Now, what do I mean by zeros to the right of significant digits after decimal place? Well, here are some examples right here that I want to show you. So 6.200 kilometer. Okay. The reason why these zeros are there is because the person who is measuring this distance is confident about these zeros. Unlike right here with Pikachu, where this number is not very confident. But these are confident. That's why they're there. So if you're confident about these numbers, are they significant? Well, of course, the answer is yes. So this is what I meant by zeros to the right. So right of a significant digits. Okay? And they're after the decimal. It has to be after the decimal. I'll show you a situation where if it's not, what are you going to do? Okay? So in this case, the answer is 4 because all those zeros will count. Just like this one, 2.0 meter. This is going to be 2 because that 0 will count. It's to the right of the decimal and they're significant. Another one, 20.00 millimeter. Okay, will all 3 of these 0 counts? Certainly. That will be 4 significant digits. Okay, and what about this? 0.00220. Okay, now this is a special one because we need to know the fact that these one won't count, but this one will. Okay, due to rule B and rule C. So the answer to this one is going to be 3. Okay. Hopefully I covered enough that you get a good grasp in terms of how it's working. So let's take a look at the last case. This is called the ambiguous case. And so you may be thinking, what's so ambiguous about this? Well, if the zeros is before, I guess you can say to the left, of a decimal point. Like for example, 6,200 grams. Okay. Are these two zeros going to be significant? Would it count as a significant digits? Well, what could it be? Okay. Now, this is the part where it's a little weird. Some say, okay, this is 2 significant digits because these ones don't count. Some, they will say, it's 4 significant digits. They will all count. Now, I can even make this 3 significant digits if I like. So why is this an ambiguous case? Well, it is because it depends how you report it. That's the idea. How are you going to report this? Because in this case, you can report it in anything. Okay? So, what that means, let's write this down right here, these 2 zeros. How are we going to report this? So, we can report to 2 significant digits. No problem. We can report this to 3 significant digits, and we can report this to 4 significant digits. Okay? It all depends, and there will be a case where you're going to have to exercise that later on. So, if that's the case, how are you going to report 6,200 to 2 significant digits? Okay, how are you going to report this as 4 significant digits? Well, there's really only one way to do it, and that is to use something called scientific notation. And that's exactly what we're going to try to do. Okay, how do we turn 6,200 into scientific notations where we can, report that number in 2 significant digits, 3 significant digit, and 4 significant digit. So let's do that. Let's do that. Let's clear this page. Okay. Well, what I'm expecting you to do, of course, is to write these things down as notes, just like how you would write it when I write these things down on the blackboard, or whiteboard. All right. So 6,200, right? How would I report this in 2 significant digits? Okay. What is scientific notation that I wrote? Well, scientific notation is based on a number, point, something, times 10 to the power of, depending on how many times you move your decimal point. Okay, so you have 6,200, 6,200 grams. The decimal point is theoretically right there. Okay, if you were to report 2 significant digits, you will have to move that decimal point. You will have to move that decimal point to 1, 2, 3. Okay, 3 places to the left. When you do that, this becomes 6.200 gram. I shouldn't write gram yet. 6.200. Now, obviously, 6,200 is not the same thing as 6.200. That's ridiculous. Well, that's because I'm not done here. I would have to say times 10 to the power of how many places I moved that decimal point. So it looks like I moved it 1, 2, 3 times. So it would be in the power of 3 gram. Right? You got to imagine the fact that this number is really the same as that number, really. So that's what I did here. Now I will show you more example in terms of how to turn a number into scientific notation. But as you can see right here, okay, which I'm not done, that if I were to take away those 2 zeros and just report 6.2 times 10 to the power of 3, that's how I would, okay, report 6,200 in 2 significant digits, because that's 2 significant digits right here. This doesn't count. Okay, you're just looking at this number. So how do I report 6,200 in 3 significant digits? Same idea. Okay, it would be 6.20 times 10 to the power of 3 grams. Okay, how do I report this as 4 significant digits? Well, 6.200 times 10 to the power of 3. Because we know from the rules that zeros, okay, to the right after the decimal point are significant. So when somebody gives you a number like 6,200 grams and they ask you, hey, how many significant digits are here? Well, that's an ambiguous case. It all depends on what you want it to be. And that usually comes in to play with mathematical operation that we're going to talk about very, very soon. Okay? All right. So before I continue, okay, looking at these mathematical operation, let's learn how to turn things into scientific notations, okay? So I have pretty much 3 examples, so let's take a look at this topic. Okay, scientific notations. How do we turn things into scientific notation? So let's take a look at example 1. I have this number. Okay, 1,234,070. Where did I get this number from? I'm looking into my bank account. So I want you to turn this number and I want you to report it to, let's say, 3 significant digits. Okay, in scientific notation. How are you going to turn this number, how do you report this number in 3 significant digit in scientific notation? Okay, that should be very simple. Let's do that right now together. You get to imagine that this is the decimal is right here. Okay, and you're gonna move that. Remember, scientific notation is based on a number from 1 to 9, then point, then whatever you're supposed to report. In this case, I want to report 3. So I'm gonna move this decimal to the very, very left. Well, not totally left, but after 1. So I'm going to do that right now. I'm going to move it 1 space, 2, 3, 4, 5, 6. Okay, I'm going to move it right there. Remember, it has to be, for a scientific notation to be a scientific notation, it has to start with a number from 1 to 9. So it'll be 1.23470 times 10 to the power of, so how many times did I move the decimal point? Well, I moved it 6 times to the left, right? So therefore, it's going to be to the power of 6. You got to agree the fact that this number is really this number. But do I want to report this number? No, I don't, because I was asked to report to 3 the significant digits. 3. That means I am only going to keep these 3. Everything else, goodbye. Okay, so 1.23, because this is a 4. I will not round this to a 4, times 10 to the power of 6. That is how I'm going to report the number I see on my bank account to 3 significant digit in scientific notations. All right, let's do another example. Example 2. So what I have here is 1058.4 milliliter. Okay. And I want to report this number to 2 significant digits in scientific notations. Just 2. All right, let's do this. I'm going to move the decimal point so it will be between the first and second number. It's always going to be like that. 1, 2, 3. Okay, so this is going to be 1.0584 times 10 to the power of, how many times did I move the decimal point? Right, 4. So to the power of 4. Am I done? No, because I don't want to report this. I want to report only 2. So this is going to be 1 point. So that's 1. That's 1 significant digit. I just need 1 more. Am I going to put a 0? No, I'm not going to put a 0. Why? Because this number is a 5. Because this number is a 5, I'm going to round this 0 to a 1. So this is going to be a 1.1 times 10 to the power of 4. See? 2 significant digits. See? 2 significant digits in a scientific notation. All right, here's one that is a little different, okay? Because you're looking at the other way. So example 3. I have this number, 0.000000415. So you can pretty much see the fact, when do scientists use scientific notation? Okay, usually, most of the time, we use it to abbreviate very, very big number or very, very tiny number like we see here. I want you to report it to, again, 2 significant digits in scientific notations. All right, okay. So remember, in order to qualify as a scientific notation, like my first two examples, the number before the decimal point has to be between 1 and 9. 1 to 9. So you won't have 10 point something. You would have 0 point something. So this number cannot be 2 digits. This number cannot be a 0. No, that has to be. So with that, how am I going to move my decimal point? Well, this is what you do. You don't move it to the left, you move it to the right. So 1, 2, 3, 4, 5, 6, 7. You stop right there. 7. So this is 4.15. Now notice I did not write any zeros. There's really no need to write all these zeros. Okay, that's ridiculous. Times 10. There's always times 10. The difference is, of course, is that to the power of what? Well, I counted 7, so it's going to be 7. However, I count 7 to the right. Unlike here where I'm counting 7 to the left. I'm counting 6 to the left. I'm counting 4 to the left. No, this time I went this way. I went 7 to the right. So it's not going to be 7. No. It's going to be -7. So this is 4.15 times 10 to the power of -7. Well, I don't want 3 significant digits. I want 2 significant digits, so therefore I'm going to round this to 4.2. So this is going to be 4.2 times 10 to the power of -7. Okay? That is scientific notations. Anyway, I do have some questions where you can practice putting numbers into scientific notations, okay, and report things in significant digits, because that's actually very, very important when it comes to reporting experimental data. All right, lastly, I'm just going to finish this lesson with a note. Ooh, a note. Now, what if I give you this number and ask you, hey, how many significant digits are there? 6 balls. How about 3 sticks? How about saying the fact that 1,000 milliliter is in a liter? How many significant digits is 6 balls? 3 sticks. 1,000 milliliter in a liter. This is actually a trick question. You're not going to say 1 here. 1 here. Ambiguous case. Depending on what you like. No. When you're given something like this, you say that there is an infinite amount of significant digits. Okay? When the number is not based on a measurement, but based on a count, that has an infinite number of significant digits. How many balls is a count? How many sticks is a count? How many milliliter is in a liter is a count, not a measurement. Okay? Because this number could have been 6.0000000 to the end. It will never stop. So make sure, okay, when I give you some question to do tonight, you don't say, oh, okay, for something that is a count, you will start counting how many numbers that are significant. That would not be right. Okay? If it's a count, it will be infinite. Anyway, hey, let's call it a day. Okay? So, the next lesson, we will learn how to add significant digits, subtract significant digits, multiply, and divide. All right? So, bye now.